This is a quick overview of polar coordinates. So usually on a plane, when we want to describe a point, we talk about it in terms of x and y. So we're moving x across, or some distance across the x-axis and some distance up or down the y-axis. And that's what's known as our Cartesian or rectangular coordinate system. So instead of doing that and talking about it in terms of x and y, we can actually describe a point in terms of the exact distance it is from the origin instead of having to do x and y. And so that's what we're going to call our polar coordinate system. And the coordinates of a polar point are represented here with r and theta. So with this diagram here, we've got a polar coordinate system. Here's our origin O, and here's a point P. And instead of doing x and y here, like x and then y up this way, we're going to note this with r and theta. So r is the distance from O to P. So like as mentioned before, it's just the exact distance from the point to the origin. And theta is the angle from this polar axis down here to the line segment OP. So here's just some quick illustrations. I've got a point P given by r and theta. So r is 2 in this case, and theta is pi over 3. So here's our polar axis on here. Theta equals pi over 3, which is 60 degrees. So the line segment is going to be directed at 60 degrees and with the length of 2. I don't know what kind of 2 that is. That's how long I drew that. So the next one, where r is 3, I just made about 1.5 of these. So, but when you're actually doing it with a ruler, you can measure however you want. With Q, we've got 3 and 3 pi over 4. I know that 3 pi over 4 is 135 degrees. So that line segment is going to be directed at 135 degrees here, and r is 3, so it's going to be 3 units out. So here it is, 3 pi over 4.